Good day to you wherever you are listening to me, watching this video. In my last video, I attempted to explain the uh, analysis of variance, and within the analysis of variance, we were able to actually understand the theory behind it. So, in this particular video today, I would be demonstrating how to carry out this analysis um, using this data set. The dependent measure in this data set is interest in mathematics, and the independent variable, which is nominal, is the method of teaching. So invariably, we have three methods of teaching, and I will take us to the variable view so that we can have the understanding of uh, the method of teaching as it were. So wherever you one is the code representing the lecture method, two represents the play method, and three is music maths or maths music, whichever way it is done. So simply, like we have said in our earlier video, to carry out the analysis of variance, you go to analyze. I will show us two ways to go about it. And when we go to analyze, we select one way ANOVA. When you have the one way ANOVA selected, you will now have uh, the factor, which is your method of teaching. You select it, and the next thing is you select the dependent measure, which is interest in mathematics. You select it. So when you have selected these two, you now go to these dialog boxes to see do some selections. Leading among the selection is to select the options, and you can check the descriptive, you can check the homogeneity of variance, you can check the Welch test and the mean plot possibly. When we get to the interpretation, I will give you a briefing on why you need to check those things that we have checked. But basically, the descriptive will inform us whether the mean, standard deviation, the homogeneity of variance test will tell us about whether the variance in different groups are homogeneous, while the wedges and the mean plots will be adequately interpreted in due course. So I'm clicking on continue, and next is to check for the post hoc analysis, and I also want to check on the Benferroni. You can also check Shefe, but the Bonferroni is quite robust compared to others, although there are rules to select the particular uh, uh, test which we want to use for our post hoc, but uh, that is not the focus of this current video. So you click on continue after you have done that. So now next is to say okay so that the analysis can commence. So we have our results. You can see that the result shows us a lot of details. For instance, if you check this place, you will see that the mean score for the group exposed to lecture method is 58.6. Those exposed to play is 68.1. Those exposed to math music is 80.9. Don't forget that this Levin test of homogeneity, I told you before that if the significant value is greater than 0.05, that is showing us that the the assumption of homogeneity of variance is satisfied and we can continue. So we are doing the right thing. If this assumption is not satisfied, I will explain what you have to do in order to take care of the assumption in case it is not well satisfied. But in this case, in point, the assumption of homogeneity of variance is taken care of in the study that we are carrying out. So as soon as we have the confidence that, so we would now begin to explain the results like we have started. So the play people, the people exposed to play, they are 68.1, and the music maths group had 80.9, which is the highest of the three groups. So now what ANOVA does is to actually compare these three mean. And the logic is just that there is a comparison of these three, which is the F test. Now, when we have this F test, we need to consider the following details on the table. Number one, the F value, the significance of that F value. So here we have a significant F value, meaning that the result obtained, the difference among the three set of mean score is actually significant. So the variance is actually significant. So these groups are different significantly in terms of the score. Also, here we have the degree of freedom between group and the within group degree of freedom, as it were. So this is 2 minus 1. Sorry, this is, we have three groups. So that's 3 minus 1 that gave us these two. Then within group, we have 30 students, and 30 minus 3 gave us this 27. So the total is the addition of two. Now, I don't want you to worry about this, this robust test of equality of mean. I will go back to it towards the end of this video so that you could have an understanding of what it is all about, basically. But now we already know that there is a difference between these three set of mean. So the next thing is to actually look at where does the difference lies? Where is the difference lie? And you will see this table here. We have high, which is method of teaching. We have J, method of teaching. So this table is actually a multiple comparison table. Is post hoc analysis where we are comparing the mean of the group with each other. If you go down this table, you will see that we have music maths being compared with lecture, and also music maths being compared with play. And the difference in their mean is this I minus J shown on this table. If you come down here, you can see that the music maths had 20, the difference between the mean score. So the mean score of the music maths students exposed to music maths was 22.30, greater than that of lecture method by 22.30. Music maths is also greater than play. So this comparison runs a t-test. You can refer back to the t-test table and to consider what this difference that we have seen, whether it is significant or not significant. So basically, if you look at this table, you will understand that the significant value of this 22.30 is significant. That means the difference between music maths and lecture method is significant. It's not something that happened accidentally. It is significant. Yeah, it's not chance. And music maths is also teaching students with music math this the achievement they will have is better than play method, which is 12.8, and the significance is also there. If you check this table now, we are now checking play against lecture method. So you will see that play and lecture method is 9.5. That means even although music is better than lecture and play is also better than lecture method. And the difference is also equally is equally significant. So all these other parts of the table, they are saying the same thing, but I didn't want to bore you with it. So we now know that what is actually happening is that the F value we obtained that is significant was as a result of the significant difference between music and lecture method, between music maths and play method, and also that between play and lecture method. The three differences that we have seen is actually accounting for the difference. Play and lecture method is different significantly. Music and lecture method play is music and lecture method is different significantly. Music and play method is different. So we have three differences that is within that has taken place. So as a result of that, if we are to recommend, the best to recommend is music maths. Then if we don't have music maths around, play can also do the job compared to achievement. And this graph actually depicts the differences that we can obtain in terms of the mean score. It gives us a graphical illustration of what we have obtained. Now, back to the last part of the video where I want to talk about uh, this Welch test of equality. What happens is that let's assume that this one, which is there's no homogeneity. That means the significant value obtained here is less than 0.05 under the test of homogeneity. You have to refer to this Welch test to do this ANOVA. You know that most of the time the result that you obtain in this Welch test and this F test will almost be the same. But you refer to Welch test if there is no homogeneity. We already have homogeneity, we don't have to. So if we are referring to the F test, we are going to also have the same result as it were. Now, I want to quickly run this same analysis going to the general linear model because I want some information such as, so under the fixed factor, I'll put the method of teaching, and under the dependent variable, I'll put the interest in mathematics. The post hoc is also the same as we have it. We can choose the Bonferroni, which is suitable for all, irrespective. Then, if you go to this option here, this is where I'm going. You discover that it can give me the estimated effect size, the descriptive, the homogeneity test. I came here because the other one I ran did not give me those uh, three, uh, uh, and I can also compare main effect using Bonferroni. So here I click continue, then I say okay. I can do plots too, uh, just horizontal plots of, then I say continue. Then I will just add this, then I say continue. The reason I came here is because I actually wanted a result to give me the partial eta squared. And this is the result that I am interested in. If you check this, everything remains the same like the previous one. But know that the previous table did not give me the partial eta squared, which is here now. This particular 0.958. Look at it. The F result is the same as in one, but the partial eta square is telling us the percentage contribution of the method of teaching to the total variance that is accounted for, which is 95.8%. That means that the student's interest in mathematics is accounted for by 95.8. The method of teaching accounts for 95.8% of the total variance of those students. That means the method of teaching is a very significant aspect when it comes to uh, teaching mathematics. So that's the additional information that we are always having in that approach of doing this particular work. Thank you for watching this video.